today we're going to be talking about what's called the ambiguous case for the law of sines, which that kind of doesn't seem very clear. That's why the word ambiguous is used. Right now we have different scenarios that can happen. You'll notice we have a case 1 right here, and we also have a case 2. Case 1 is where the angle is an acute angle. So anytime angle A, right here, is less than 90 degrees, we're going to refer to this chart. If angle A is greater than 90 degrees, all right, or equal to 90 degrees, we're going to refer to this chart right here. Okay? So right now we're going to look at problem number 1, and we're going to figure out which one of these particular scenarios is in play. All right, so we have angle A, 42 degrees. Ooh, that means we're dealing with an acute angle, which means we are definitely in what? We're in case number 1. All right? Now, after you figure out which case you're in, you're going to write the A value and the B value. Underneath A, you're going to put 22. Underneath B, you're going to put 12. And you have to ask yourself, is A greater than, less than, or equal to B? Well, obviously, A is what? Greater than B. Oh, horrible. There we go. Greater than B. Now, let's think about where this one fits. This is right here. All of these three is if what? If A is less than B. Over here, this is where A is greater than B. So right now, it looks like we have what? One solution. So when it says determine the number of possible solutions, answer number 1 would simply be what? One solution. Now that in and of itself doesn't make a whole lot of sense yet. So we're going to do a picture that goes with this and make sure that you understand how this would work. So right now, what I'd like you to do is make a nice straight line. We're going to get our protractor out, and we're going to make a 42-degree angle for angle A. Now I realize you don't have a protractor with you, but just estimate with me if you would. That's about 40. That's 41.63. That's pretty close to 42, so that's my point right there. We're going to draw a line going through that point, which means right here is a 42-degree angle. This is capital A. And once again, my A value was what? Equal to a 22, and my B value was equal to 12. So I want you to understand, this part right here is lowercase b, and A is 22. So I'm going to understand, 22 is a heck of a lot bigger than a 12. So let me draw a triangle that would probably best fit this scenario. I call this lowercase a. I'm going to erase everything going to that. This right here is capital B. We'll make this capital C and lowercase c. Now, this is not perfect, but I want you to understand, A is a lot bigger than what? It's a lot bigger than our B value. So if I said B is from here to here, and that's 12, then this distance would be what? Almost twice as big. This is the only triangle that can be made. You can only have one triangle that's made from this particular situation. Can I take this side right here, and can I swivel it, if I keep the same distance, can I swivel it across anywhere inside to make another triangle? I can't. So if you're wondering what those dotted lines are in the picture, here's what the dotted lines mean. They're referring, if you had a compass, see this. Where's my compass? Let's try it one more time. Come on, compass, where are you? Looks like I lost my compass. So it won't work. But imagine, if you would, imagine if I tried to take this and use the compass to arc it going across. You wouldn't be able to arc it to make another triangle. All right, you only have one possible solution. So hopefully I can get my compass working here in a little bit. So right now our answer is what? One solution. You can only have one triangle based off of this information. Now we're going to go to problem number 2. Okay? Problem number 2. Once again, we have a case number 1. We list our A. We list our B. Our A value is 15. Our B value is 25. Now we have the situation where what? A is less than B. So let's go over and check our chart real quick, all right? So if A is less than B, we have to plug in right now. We have to plug in B sine of A, B sine of A, B sine of A, and see which one of these parts best fits our situation. So you have a graphing calculator. So right now what we're going to do is we're going to write in B times the sine of A. Our B value is 25. Angle A is 85 degrees. And we got to see what is this, how do these compare? So go to your calculator. Type in 25, sine of 85, and you're right. It says what? 24.9. Well, how do I use that 24.9? So this right here was equal to 24.9. 15 is way less than 24.9. And so what do we, basically, let's look at our chart. Go back to our chart, and what does that say? A is what? Definitely less than B sine of A. Therefore, how many solutions are we going to have with this possible situation? None. We're going to have none. We're going to have no solutions. Now I'm going to draw a picture. That's a great question. I'm going to try to draw a picture to help you understand why. Now, the math part is A was actually less, our A value was less than B times sine of A. That's why there's no solution. But I'm going to draw a picture as best as I can. What was our angle? Our angle was what? 85 degrees. So if that's about 90, let's say 85 goes about like that. Okay? This represents side B. This is capital A. This angle is 85 degrees. And what did they say our side length was for lowercase a? 15, right? Well, let me explain something. If B, everybody, is equal to 25, and I said my A value is what? 15? Let me explain something. You guys see how this would have to go all the way down for it to make a triangle? Well, does this length of this green side seem bigger or smaller than a side that's 15 units? If this is 25, right? This is 25. This side right here would definitely be way too big. 15 is going to put you right about here. So no matter where I put this 15, is this ever going to make a triangle? Never going to make a triangle. So I'm just going to put, this could be 15 all day long, which represents what? Represents your side A. And what's never going to happen? It's never going to be able to build a triangle. Let's go back to our picture. See right here? Here's our situation. You see that arc right here? This is saying, oh, it's never going to quite do what? It's never going to quite touch to make a triangle. That's why the situation is no solutions. Okay? All right, now, let's go on to problem number 3 and see which case we have. Problem number 3, this will be the last one we do in the video. All right? We have our A value. Ooh, case 1. Why is it case number 1? Because of that 58 degree angle. We have our A value, which is a 4.5. We have our B value, which is equal to a 5. A is definitely less than B. But if A is less than B, what's the next thing we're going to do? We have a test. What's the test? B times the sine of what? A. So right now we're going to write 5 times the sine of 58 Right now we're comparing 4.5 to that. 4.5 in comparison to a 4.24. 4.5 is greater than that. Ooh, you're right. So this right here, if we go back to our chart, what happens if A is greater than B times the sine of A? Let's go back. We have what? Two solutions right there. Okay? Now, let me draw the picture that goes with this, and hopefully this will make the most sense out of all of them. Why is there two solutions? Okay? So right now, write down your answer. Two solutions. All right, let's do our best to draw this out. All right, I'm going to get some grip here. Okay? So right now, if I draw right here, this length, okay? And what was our A value? Our A value was equal to a what? 4.5. And our B value was equal to a 5. And what was the angle? What was angle A? 58 degrees. All right, so right now I'm going to get my protractor. I'm going to put right here. I'm going to try to draw a 58-degree angle to the best of my ability. That's 58.39. That's pretty close. So I'm going to draw a 58-degree angle going through that. Now, 4 units, 3 units, if I kept going, it's about 5 units, okay? If I use the Pythagorean theorem, up 4 over 3, we'll reduce it a little bit. That's about 5 units right there. So my B value right here is equal to a 5, okay? What is my A value going to equal? My A value is what? 4.1. 4.5. So let me explain right here. I'm going to put that distance down right about like that. So what if I said that this side right here is 4.5 units, which represents our A value? So right now we have what? We have A, we have B, and we have C. Well, watch what I can do. I can actually make another triangle with that 4.5. That could go here, or watch. Can you see how this distance from here to here, I could also say that's angle B, and this distance right here, these represent the exact same length. So what's this distance? That's also a 4.5. So what does this mean? This means I could have actually not one, I could have 2 different triangles. I'm going to draw those 2 triangles and split them up, and maybe you guys can see what I'm talking about. So we have this distance here, we have this distance here, and that distance. Or we have the original, where we went like this. So one of our possible triangles could be angle A right here. Change to blue so use it, matches it. Angle A, angle B, angle C, angle A, angle B, angle C. What hasn't changed? Angle A in both cases is what? 58 degrees. What also hasn't changed? This side is still 5, this side is still 5. And what does this represent? This represents side B, this represents side B. What also hasn't changed? Yeah, that's 4.5, which represents side A, and this is 4.5, which represents side A. What has changed? What's the only thing that changes? What angle C could be, and what side C could be. We have 2 different what? Possible answers that have the same angles, and they have what? 2 out of the 3 sides that are the same. But yet you have 2 totally, distinctly different triangles. This is why the answer is what? Not one solution, but you could actually have 2 solutions. 2 solutions means what? It means you could actually have 2 different triangles based on this given situation.